All right, well, let's do this. Uh, Thanks for coming. Appreciate everyone that's here. My name is Michael McCarty. I'm at Edge Fall Protection. Um, just a couple logistical things before we get started on this. This course is being offered for AIA learning credit. So if you need continuing education units, shoot me a message after the fact, and I will get your AIA number inputted for that. Um, and then if you have to leave or you skip something, just feel free the recording will go out after the fact so you guys can watch this later. If you have any questions, feel free to drop those in the chat. We will answer those towards the end. And always makes it a little more fun if we can engage with some questions. So please contribute and ask some if you have any. And then finally, just a quick little bit about Edge Fall Protection. Based in Minnesota, we work across in all 50 states. We do design, engineering, procurement of materials, and installation. So really have a turnkey fall protection solution there for anyone and everyone. We really specialize in rooftop fall protection, but we do a lot in manufacturing environments as well. So anyone has any questions or anything, feel free to reach out to me, or anyone on our team is more than happy to help you. And even if it's not something that we specialize in, we're happy to point you in the right direction. So lastly, we will be having some poll questions. So as those drop in, feel free to contribute there as well. Wonderful. So today, what we're going to be going over today, definitions first and foremost. What is a authorized, competent, qualified person? What do those things even mean? We'll be going over the hierarchy of fall protection, the ABCDs of fall protection. We'll be talking about OSHA updates subpart D, which is kind of its most recent update. We'll compare and contrast fall protection requirements between OSHA and IBC. These things work in tandem, but don't marry up perfectly. So just want to highlight some of those variances between the two. We'll talk about specific rooftop hazards, some solutions there, and also just penetrating versus freestanding fall protection. There's a lot of different products and solutions out there. If you Google harnesses or SRLs or lanyards, there's almost a nauseating amount of solutions. But what we're trying to focus on is the whole solution. So how does every different component fit into the envelope of a building? Because you need all the components to make sure you have a functioning system. And looking at the penetrating versus non-penetrating options of fall protection. Both have pros and cons. So finally, talk about inspection requirements, tests and certifications, and then finish up with any questions that anyone has. And then if you do have a question, just unmute yourself. So OSHA definitions, authorized, competent, qualified person. These are kind of the main three that we have. An authorized person, an employee who is assigned or approved by their employer to use fall protection. You onboard an employee, it's your first time working at Edge. We give you a 4 to 8 hour course saying, this is how you don a harness, this is how you use a lanyard, this is how you attach it to an anchor point. You are certified to use these PPE, these components of PPE in this specific instance. So you really shouldn't go outside of your scope of work. So if you're trained on climbing ladders, you should really only be climbing ladders. If you're trained on horizontal lifelines or some other components, you want to stick to what you've been trained on. So a pretty narrow definition and pretty specific training for authorized person. The next tier up of that is a competent person. This is someone who's authorized to identify and correct fall hazards in the workplace. So we provide competent person courses. There's places all across the country that do this. And what we and those other organizations are trying to do is to teach an employer to be able to identify their own hazards. Because you're going to know your facility the best, why don't you get some training, understand, hey, this is a hazard, and then also how do I modify or use PPE to ensure that with this hazard, I can adjust for it and make sure that people can work safely. So that's usually an 8 to 16 hour course. They have some 5-dayers there as well. And then the third most most robust form of qualified person is a qualified person. So this is someone who's in possession of a degree, certificate, professional standing. who can identify and solve problems related to fall protection. So these are generally engineers, so people that are designing the ABCs of fall protection, which we'll go through and which we will review in a second. But they have formalized education. You could be maybe a certified safety professional with many years of experience and be a qualified person. But if you need to do some math or some calculus to figure out what the loads are on a structure, that's not an area where you should provide expertise unless you're trained for it. Wonderful. So next, hierarchy of fall protection and the ABCDs of fall protection. So the hierarchy of fall protection, and we have a quick question that Colton popped up for you. So all 6 or 7 of you can answer it. So all right, so we got some competent people, some qualified people, and then none of the above. Good little mix there. So as far as the hierarchy of fall protection, this is a way for us to conceptualize how to identify hazards and how to use fall protection. So when we are teaching this at Edge, this is kind of the first thing that we teach. It goes from most effective to least effective, and we want to stick with the most effective first. So eliminating the hazard is the first thing that we think about. That means physically removing the hazard. So people generally skip this step altogether, and they don't think about how they could remove a individual out of a dangerous situation. They just try to provide fall protection or provide a solution immediately. When if we just took a step back and thought, hey, can we eliminate the need for this person to be at heights altogether? That would be an ideal situation. A good option of eliminating a hazard might be on the corner of buildings, you might have a light bulb. So using an extension post to unscrew and screw in a light bulb is going to be better than having a person get in a ladder or a man lift. There is a facility in southern Minnesota I was at recently that had valves, 30 feet up in the air that had twist offs. So could we have brought those valves down to ground level? Maybe yes, maybe no, but that's eliminating the hazard. People don't have to tie off. We had to install fall protection for them to do this. They don't have to tie off. They don't have to get at heights. They're just safe working at the ground. And then I lost the last one that I was going to do. But so eliminating the hazard, again, best one to do. If you can do it, please do that. If we can't eliminate the hazard for some reason. Oh, and I remembered. So if you're going up a ladder, you have to use some sort of personal fall arrest system if that ladder is over 24 feet. Switching from a ladder to a stair, which we're seeing a lot of these days, you're not exposing a person, you're exposing a person to heights, but they have guardrail all the way around them. And it's kind of a better option than climbing up that ladder. So number 2, the second most effective form of fall protection is passive fall protection. What does this mean? It's guardrail. Guardrail is simple. It is in place. You don't need to train anyone on it. You don't need to do a recertification of it. You need to do, maybe PMs periodically on it, but it exists, it's passive, and people are protected. So we are leading. If we can't do eliminating the hazard, we're leading with passive fall protection 100% of the time. If we can't do passive fall protection, the slope is too great, we can't attach to the structure, we can't have a freestanding system, whatever it might be, then we're going to switch into active fall protection. So active fall protection includes fall restraint and fall arrest. Fall restraint isolates people from the hazard. So both fall restraint and fall arrest have the ABCs of fall protection, which we'll review in a second, but they have an anchor, body wear, and connector, and the restraint system prevents someone from going over the edge. So if you have an anchor point on your rooftop and it's 10 feet away from the edge, I would give you a lanyard that's 8 or 9 feet. Anything less than 10, a person physically cannot get to the edge and fall off. So we're using this restraint system as kind of like a dog leash to make sure people are not going over the edge, which is in contrast to a fall arrest system. This is stopping a fall if one should occur. Restraint, arrest is arresting the fall in the event of it happening. So someone does go over the edge, that system will engage, and it will prevent someone from hitting the ground and hopefully injuring themselves severely. And then lastly, we have administrative. So this is team communications. This is definitely the least effective form of fall protection. It's often seen as, you get hired to a new facility and they say, you cannot go on the roof, sign this piece of paper. You can't go within 15 feet of the edge, sign this piece of paper. You cannot perform this work, sign this piece of paper. So it's administrative, it's communicating what the hazards are, but it doesn't prevent people from really exposing them to hazards. Again, feel free to unmute yourself and hop right in. Moving on, ABCDs of fall protection. So the A stands for anchorage. There are kind of two different types of anchors that exist out there. We have a non-certified improvised anchor, and then we have a certified or engineered. Non-certified, you hear this number probably a lot. It's the 5,000 pound rule. If we engineer an anchor, it must have a breaking strength of 5,000 pounds. So, we're working in a manufacturing environment. We want to tie off to an I-beam. Maybe we put a beam clamp or a beam wrap around that I-beam. And a competent person, remember there's authorized, competent, and qualified. A competent person, the middle one, can look at that beam and say, that can support 5,000 pounds. What's 5,000 pounds? One block of the Pyramid of Giza, 5,000 pounds each, or a rhinoceros. So if you want a fun visual, you can think, can a rhino hang from that I-beam? If the answer is yes, you can tie off to it. So that's improvised, non-certified. And then we have certified or engineered. So the certified or engineered anchor point is going to be an anchor that's designed to a 2-to-1 safety factor of a MAF or max resting force. Now, this certified or engineered anchor should be designed by, again, those definitions, a qualified person. And that person is going to say, hey, the max resting force, the max force that's going to be exerted on a user is going to be X. So let's say X is 1,800 pounds. If that is the max resting force, we're going to engineer that anchor point to 2 times that MAF. 18 times 2 is 3,600 pounds. So that's a significant decrease. And when we're thinking about how do we design buildings, how do we attach to buildings, how does our fall protection integrate into the envelope of the structure, this is a good thing to consider, because you might not have capacity on your structure to install an anchor that meets a 5,000 pound test, but you might have capacity at a 3,600 pound. We can get it lower, it fluctuates just depending on what type of solution that we're using. But really good idea to kind of get people, companies like us, involved early on, so we can make sure, hey, this structure is robust enough. We can do a 2-to-1 safety factor. And just some things about anchorages. We want to make sure that we're installing, what type of substrate is it? So this roof in this picture here, we have a membrane, white roof. What's the deck underneath that? Is it a steel? Is it wood? Is it concrete? How thick is the concrete? What's the PSI? If we're attaching to that I-beam, that's obviously going to be steel, but how thick is the web, the flange, all those sorts of things. And really the type of substrate that we're attaching to is going to play the biggest factor when we're attaching to anchorage, or when we're creating an anchor. Wonderful. So B's, body wear. This is your harness. So a lot of different types of harnesses out there. Full body. You can see in the left-hand picture that we have, D-rings that will provide limited access. We have a chesting D-ring on that person for ladder climbing. We have some positioning systems around the hips and suspension systems as well. The most classic, most common one that you'll see in almost every harness, I think every harness, is going to be that dorsal D-ring that's on the back of the individual's harness. So we want to make sure that this is inspected before each use. The inspection doesn't need to take 10 or 15 minutes. It is a once over of your system, a once over of your harness to make sure it's in good working order. None of the impact indicators have been ripped and pulled. There's not significant rust on the D-ring. stitching is intact. Does it look good? And you should have your own harness. Each individual should have their own harness with their name on it so that they know it fits well. They're not swapping harnesses with other people. It's comfortable. And then you're responsible for the maintenance and making sure it's in good working order. If it's not, we need to obviously not use that. So inspected, each use is an authorized person, and then a qualified person should inspect a harness annually. Again, comfort and use. If you're doing a ton of movement throughout the day, you might want a super light harness if it's middle of the summer in Kansas. But if it is slower, more methodical work, maybe you're hanging, you might want some cushions in your harness. So get what works best, because a comfortable harness is a harness that someone's going to wear, and that's what matters the most at the end of the day. So for the C's, the C is the connector. The connector can take a lot of different forms. We have lanyards, we have lifelines, we have SRLs, self-retracting lanyards. People call them yo-yos, blocks. They have a ton of different names. And they're all specific to certain instances. So things to consider when you're picking one is it really should be specific for a specific use. I talked about the fall restraint versus fall arrest. Let's say that you picked a SRL that was a 10-foot SRL when you only have 6 feet to the edge. So but the system is designed for fall restraint. So we picked the wrong connector there. So making sure that we're using the right tool for the right project, right? Things that we need to consider: free fall and total fall clearance. Some of them, your class 1 connectors are going to have a max free fall of 2 feet, where your class 2 anchors is going to have a max free fall of 6 feet. So in this example to the right here, this was a system that we designed for a facility, a warehousing facility. And you'll notice that we have to incorporate a lot of fall clearance calculations here. So in that fall clearance table on the bottom left of that picture, you have dynamic cable deflection, because this is a horizontal lifeline system that destroys itself as it absorbs energy. We have SRL, deceleration distance. So in this case, this is a class 2 SRL, so 24 inches. Harness stretch, safety margin. The person was kneeling, so we had to add additional there. So you have a lot of distance that person can fall before they've completely stopped. And you'll kind of see that the user's feet are just a couple inches above the ground. What did end up happening here is when we went to do a field verification of the dimensions, was that this structure was not as tall as we thought it was. So we had to, when we redid the calculations, the user would have hit the ground. So we had to switch from this system to another system entirely. And we couldn't have used a different class because we have to use 24 inches as the maximum. But the point is, make sure you have the right connectors. Make sure that whatever the deceleration distance is, if you're working at 4 feet, that SRL, that lanyard, needs to catch you fast. So pick the right one for the right application. These descent rescue. So this is the one that doesn't get taught as much or talked about as much. Calling 911 isn't really a rescue plan. It is what you should definitely do if there's an instance where someone's been hurt. But a rescue plan is a prompt communication of less than 4 minutes with the user that may have fell. It's simple. And we can use a lot of different things for a rescue plan. We can use a ladder, we can use a boom lift. You can make a 3-to-1, 5-to-1 mechanical advantage pulley system. You can use a rope with an ascender. On the right-hand side, that's our team practicing with a rope with an ascender. And it's really important to practice. At the end of the day, you're going to default, in a stressful environment, you're going to default to your lowest level of training. You're going to default towards, it's the weakest link in the chain idea. So make sure that your folks are practicing this and they're up to snuff on it. Other thing to consider here is that a person might not be able to self-rescue here. So practicing with an ascender, but that's assuming that the user is conscious, and they may not be. Maybe there was a swing hazard and they hit the wall or a beam, or they hit their head on the way down, and they have heat stroke, and that's why they fell off. So considering those different components, super important to make sure that we have an option to get the person down from heights as soon as possible. Great. OSHA updates, subpart D. So this is a big one that's come out recently. But OSHA provided some real clarity on when to use fall protection for two main locations. Number one, on the rooftop, they said that anything within 15 feet of the edge, you need some sort of fall protection. IBC, which we'll get into later, has more of a 10-foot rule. It was a 6-foot rule prior to this. There was a lot of confusion on when should you have, at what distance from the edge do you need to implement some sort of fall protection. It's 15 feet. They cleared it up, which is nice. And then the second most impactful thing, no cages on ladders anymore. Since 2018, and I was at a retreat for specifiers with architects and engineers really recently, tons of ladders being spec'd in with cages, but those should not exist. They should not be installed past 2018. What we are doing going forward is any ladder that is over 24 feet needs some sort of fall protection. Generally, that's taking the place, or that looks like a personal fall arrest system. So a cable system similar to what you see in this picture. There's some track systems and some other ones. But that should be installed on any ladder over 24 feet. This is compared to what we used to do. Any ladder over 20 feet got a cage. So we have until 2036 to switch all the existing ladders out into a ladder that is can accommodate a personal fall arrest system. This doesn't mean that you need to install a new ladder. It just means that you need to add a personal fall arrest system. But if your current ladder is not compatible with a personal fall arrest system, then you might have to swap out the ladder. What kind of impact is this going to have? Anytime OSHA does a change, they expect that it'll reduce fatalities by 29 and reduce lost workday injuries every year by a little over one a day, by 5,200 and 5,842. You guys can read it. Sorry, I tripped over the words there. Great. So fall statistics of 2022, these are our most recent numbers. BLS provides them just a little bit delayed, but there's been 5,486 fatal injuries in the workplace. That's a ton. 865 fatal injuries from slips, trips, and falls. So 15.7%. Slips, trips, and falls is always in the top three, unfortunately. That's 2 people a day that are dying from this. So it's the number one cause of workplace deaths in construction industry. Fall protection is the number one most cited OSHA standard. Fall protection training is the number 8 most cited. It's 100% preventable. We can do a lot better at protecting people at heights by first education, like webinars like this, but also just making sure that we hold our co-workers, employees, employers to a high standard. Awesome. What are building owners and employers doing? You got a little question there for you. So perimeter guardrail systems, that's probably what we're seeing the most of. Again, we talked about what's the simplest way to keep people safe at heights, besides eliminating the hazard, which can get expensive, is passive fall protection. So we're seeing a lot more guardrail systems around the perimeter of roofs, both freestanding and penetrating solutions. We're seeing a lot more controlled access zones. So warning line at 15 feet anytime it's a permanent fixture there. That 6-foot rule is temporary and infrequent. Really, it's only roofers that can use this sort of rule here. We're adding a lot of rope descent systems, fall protection anchors to existing and new buildings. I think I got a question here in a sec, but give me 1 second. And then increased training, which is great. Again, these webinars, going to a competent person, authorized user, anyone will give you more information and knowledge. So get your people out there to get that training. Rope descent system, anchor certification, so that's good as well. And then adding a ton of vertical lifeline systems to all ladders over 24 feet or greater by 2036. Did I hear a question?
Yeah, I was just wondering your thoughts on that temporary and infrequent 6 foot zone. I get a lot of questions on that, and then just seems like there's not a lot of guidance from OSHA that defines what temporary and infrequent truly is.
Yeah, I agree. Thanks for the question, Andrew. I mean, OSHA creates these rules intentionally vague, and I think it's up to the industry. I think it's up to the individual. I think it's up to the employer to say what is temporary and infrequent. I think we should always default to what what do I need to do to keep my coworkers or my employees safe. So if temporary and infrequent, and it's a 1 hour thing, you're doing a 6 foot rule, but it's high winds or it's raining or it's sleeting, um, or there's some other element there that makes it a little more hazardous. Protect your people at the end of the day is kind of what I would default. I think people want to default to what is the rule, but I think in their hearts and their minds, people generally know, is this safe or is this unsafe? If it's unsafe, you should always protect it, whether the workers are at 7.5 feet or 24 feet from the edge. Great. So fall protection requirements, OSHA versus IBC. Again, that conference that I talked about previously, a lot of I don't know if it's misinformation or just unaware of the rules and the difference here. But let me just go over it so we know. OSHA general industry. So that's 1910. Anytime a user is at a height over 4 feet, we need some sort of fall protection. Doesn't matter what it is, guardrail, passive, active, restraint, whatever. Some sort of fall protection at any heights above 4 feet. Where do we normally see this? Loading docks. Loading docks are always right within that 4 feet requirement. So again, that loading dock can be under 4 feet. If it's a hazardous situation, protect your employees. Where else do we need fall protection? We talked about this previously, but anytime you're within 0 and 15 feet of the leading edge, fall protection required. Anything over 15 feet, so this is that permanent solution that we were talking about. We want a permanent visual warning line system at 15 feet to clearly communicate to folks on the roof, hey, you can't go past this visual warning line system. You can't go along the roof edge. This is in contrast to IBC roof access, which says fall protection required if a roof hatch or mechanical equipment is within 10 feet of the leading edge. So what I have seen a lot, and what I have a lot of conversations about this, is an architect or engineer has designed a roof hatch to be at 12 feet. So they are past that 10-foot rule. Someone's getting out of the roof hatch, they're on the roof, they're at 12 feet from the edge. They get their certificate of occupancy. They design it for that. They get their COO, and then it changes hands from the construction company, architects, engineers, whoever's building the building, to the owner. And that owner is responsible for his or her employees. And that rule is now defaulting towards OSHA. So OSHA, being anything within 15 feet needs fall protection, that roof hatch is no longer compliant at 12 feet. You need some sort of fall protection. So something to be aware of if you're designing systems, make sure you design it. Get it out to 15, 16, 17 feet if you can. If you can't, and it needs to be within 15, let's put some guardrail around it. Let's set up an anchor so we can attach to it and keep folks safe. All right, just covering a couple of the rooftop hazards here quick. I don't want to spend too much time here, but the most obvious one is leading edges, perimeter of buildings. It's an unprotected side, edge, floor. So it's the most obvious thing. Where the perimeter is at, which means that you should install guardrail, horizontal lifelines, anchor points, visual warning line at 15 feet. Just make sure you're protected at the leading edge. This includes anytime a rooftop changes elevation that's over 4 feet. We need some sort of fall protection in those situations as well. Skylights. These are a little sneakier. because we don't always think about them being a hole in the roof, but that's what they are. OSHA 1910.28, the employer must ensure each employee is protected from falling through any hole, including skylights. So most skylights aren't rated for fall protection. They aren't rated to have a user step on them, sit on them, lean on them. They can get covered by snow. They get exposure to the sun and UV. The acrylic can get brittle and it can make it more prone to break. You hear about hail breaking skylights, and then you imagine a 200-pound person falling on a skylight. So they'll definitely break that thing. Not obvious, the flat roofs, so corrugated, standing seam, and R-panel roofs, you often see in manufacturing environments kind of a flat skylight there. These are the least obvious. They call these the widowmaker, unfortunately, because people are walking on the roof and they just don't see them. They think that they're another part of the metal roof when really it's a skylight. So just making sure that we're protecting these. Again, guardrail, horizontal lifelines, anchor points, visual warning lines, and then we have skylight screens as well. So all the basics we can use to protect skylights, but we need to be aware of that. And even if you're in the middle of the roof, if you have a skylight, that's less obvious to know that that needs to be protected and that it's a hazard. Roof hatches are also a hole. If they're in the open position, that's a 10, 20, 40-foot hole in a rooftop that you can fall down. So make sure that you're protecting this. I think, and I'll talk about ladders in a second, but roof hatches are one of the most dangerous areas because it's the highest traffic. We're going up and down that ladder all the time. Anytime we're getting access to the roof, you're out there on a cold day, the flashing around the roof hatch is cold. You do that. You're out there on a hot day, you put your hands on there without gloves, you could do that. So it's just a dangerous transition. Sometimes the curbs are 6, 8, 12 inches from the bottom of the roof to the top of the curb. It's just a tough spot to transition. So making sure that you have a good solution there. This is kind of a customized picture in the background, but we have a really great option that compresses around the hatch of the curb. It includes grab bars. It has a self-closing safety gate. Just make sure it works for you and your team. So access and egress. So now we're talking about ladders. This is really important for emergency preparedness. When we think about dangerous caustic environments, facilities housing hazardous material, ammonia lines, fire-prone explosive environments. And what I've seen a lot of, we talked about the change of the ladder, that any ladder over 24 feet has to have some sort of vertical lifeline system or personal fall arrest system on it. A lot of folks are just switching to stairs, not because it's less expensive, it's definitely more expensive. But when you think about someone being at a food and bev facility and they have an ammonia leak and they need to get down from that as quickly as possible, putting your harness back on if you took it off, making sure you're hooked up right on the vertical lifeline or whatever personal fall arrest system that you're using, and egressing that rooftop, that can take some time. That time can make a big impact on the safety of your folks. So it's just another variable to go into the calculus of how do we protect our people? How do we make sure that we're being safe at heights? Other solutions, crossovers, ramps, stairways, ships, ladders, access ladders. We do all these things. It's what works best for your scenario is what we're going to recommend. Great. So penetrating versus freestanding fall protection. There is a lot of options out on the market for this. Fastened systems are almost always going to be a little less expensive for the material cost. But they have some cons. What we have to do with any sort of fastened system, whether it be anchor points like in the picture, horizontal lifelines, mounted guardrail, is we're going to have to do some sort of analysis of the substrate. Like I mentioned before, steel, wood, concrete, what's the thickness, all that sort of stuff. How are we going to attach to it? Fasten, weld, something else. We should get a professional engineer involved to review the attachment. Hey, is this the right attachment? And also, can these structure absorb the loads that may be imposed on the structure. Anytime you're making a hole in your rooftop, you're opening yourself up to potential leaks. If you imagine guardrail system and it has a stanchion every 6, 8, 10 feet, that's a hole in your roof every 6, 8, 10 feet. Each one of those is an opportunity to have a leak and have a problem. And the installation is just a little more involved. If it's an existing building, we might have to cut a hole in the roof, weld, drill, fasten, as I mentioned before. Maybe the concrete isn't as thick as we had thought, or isn't as thick as it should be as it showed in the drawings. You might have to do a lot of changes if we do some sort of fasten system. This is opposed to the freestanding system. So this is often a permanent solution. You shouldn't have any leaks or penetrations. Almost all of them are pre-engineered systems. They have variables and constraints. You need to stay within these parameters when you're designing or using the system. But it will work in these use cases. Installation's definitely simpler. Usually it's using ballast or weight to make sure it's providing the right kind of protection. So that might be a deterrent of using the system. Maybe we can't put a 300 or 400 pound freestanding anchor in this location. And it does have its limitations. So freestanding is definitely going to be a little higher on the cost of the product. Fasten system is going to be less expensive on the cost. You save a little money with freestanding for the installation. And then with the fasten system, you're doing that engineering review. Installation is definitely more involved there. What's going to be best? Remember that hierarchy. So as much as possible, let's make sure that we eliminate the hazard. If we can't do that, we'll use passive fall protection, then use restraint, arrest, and admin. So whether it be penetrating or non-penetrating, I'd say start with that mindset. Start with eliminating, and then go to guardrail. If we can't do guardrail, then we're looking at a restraint and then arrest system. Talking about inspection, again, we talked about how when we don a harness, every time a user must inspect their harness. And not only the harness, but every component that they'll be using. So if you are going to be using a horizontal lifeline, give it a quick visual, make sure it's not frayed, doesn't have any burrs sticking out, it's not rusted. If we're using an anchor point, which we would for a horizontal lifeline system, make sure that's in good working order as well. And then any non-user, make sure that we get an annual inspection of that. So get a person that is not using your harness, not using that horizontal lifeline, not using that anchor point, get a third party to come out and inspect it and say, hey, this is in good working order. If you don't, you're just kind of opening yourself up to some liability. As far as the actual testing of the product, so we test fall protection systems, so active or restraint systems every 5 years. So we need to do some sort of pull test or proof test to ensure that this system meets the requirements that it's supposed to meet. This is in contrast to window washing anchors, which need to be tested every 10 years. I could go into that a little bit more. I'm just going to leave that out there. But if you have more questions on that, just feel free to reach out to me. We test it to 2,500 pounds if the system's been designed for that 5,000 pound load test. Couple different standards that we use to inform that decision. But just know we aren't testing to actually 5,000 pounds because 5,000 pounds may destroy the anchor. Wonderful. And that's about what I have here. Leaving some time for questions.
Can you guys hear me?
Yes, Taylor, go ahead.
Hey, yeah, this is Taylor. I've got a question for you. I know and maybe you said this in the beginning and I hopped on a few minutes late, but does your company provides full turnkey services from you come on site, look at the situation, perform the engineering analysis for the system as well as for the support structure analysis, and then you would like spec out a specific product, like a 3M product or something that we would then go purchase. Is that correct?
Yeah, we can do all of those things, or we can do just one of them. So a lot of the times you get pulled in and just do the testing. For us, I think the best value add for us is we come in, do an assessment of your facility or location, say, here's what we'd recommend. We can generally purchase that product ourselves at a discount and then engineer it and install it. Our team is pretty familiar with most of the systems out there, but if you have a preferred one, we could always look at that as well.
Gotcha. And then from a system design perspective, I'm new to my current role, but in my previous position, we did a lot of investigation around the ladder safety systems, specifically the 3M DBI Sala cable system.
Mhm.
And we were having a very difficult time proving from a structural standpoint that the ladder rungs on our existing ladders were capable of supporting the 2x MAF loading that the systems imposed on the ladder. And I was just wondering if you could speak to, you know, the salesman pitch is, hey, you got a ladder that has a fall hazard of 24 feet. You need a system on there. Here's the system. Go slap it on there. But if you look at the 3M documentation says supporting structure shall be evaluated by structural engineer. So, you got to take load to ground. So I was just wondering, from the standpoint that you guys are doing some of these designs, how are you getting those loads resolved?
That's a great question. And that is one thing that I think is most overlooked with this personal fall arrest system for ladders, is that we're buying a product off the shelf, or people are buying a product off the shelf, slapping it on a ladder and calling it good, but not doing a structural analysis of, if this ladder is attached to some wooden studs or an aluminum stud, can that load transfer from the ladder to the structure, and can that structure absorb the load? So to answer your question, we again would do whatever's in our scope, but our ideal situation is that we're brought in and we provide an analysis of the structure, or even better, there's an engineer of record on file that we can consult and say, hey, in the event of a fault, these are the loads that are going to get transferred to the ground or the structure. And then knowing what kind of ladder that you have, if it's steel, it's going to be a little more robust, and it's going to it's a lot sturdier than aluminum, and there's a lot of aluminum ladders out there that are purchased and bought and installed, and a lot of those rungs are hollow. So in the event of a force going on those rungs, because that's what the system's attached to generally, it would crush those rungs and maybe not support or provide the support needed. So what we do is potentially reinforce the ladder, reinforce the attachments. Sometimes it might be, hey, we can't install a personal fall arrest system on the ladder, and that's a reality as well.
Gotcha. Okay, thanks.
Yep, you bet.
Yeah, one that comes up pretty often is who decides when a person is qualified or authorized? Is it an official OSHA designation, or does it come from the employer?
Yeah. So there's authorized, competent, and qualified, and it's always the employer is going to say, you are a competent person, you're a qualified person, you're an authorized person. So we can provide you training and say, hey, we gave you an 8 or 16-hour course, give you a card and say, you've received the competent person training, but only the employer can say, you are the competent person at our facility. So there's a distinction there that's nuanced, that's important.
Awesome. And then another good one is how do the fall protection requirements change on a slanted roof versus a flat roof, which is another pretty common one.
Yeah, the requirements don't change. Anytime within 15 feet, you need some sort of fall protection. If the roof is super sloped and there's a danger to employees, and you're well within 15 feet, you should have fall protection. But the application of products is going to be a lot different. So we generally can't use a lot of freestanding solutions on a pitch greater than 112 in some scenarios, 412 in other scenarios, where we can pretty much always attach to a structure and figure something out with a penetrating solution. So it's more the products that we use, not necessarily when do you need fall protection. Beautiful. Well, again, thanks for your time. Really appreciate you being here today. I think that QR code goes to a contact info for me. So if you have questions, comments, concerns, want to reach out, scan that, shoot me an email. If I don't know it, I'll try to figure out, or I'll point you in the right direction. Or feel free to call our 800 number on our website, and any member of our team will do their best to give you a hand. So with that, have a great rest of your week. And again, appreciate you being here. Thank you.
Thank you, Michael.
Yeah, thank you guys.